Yeah, yeah. I apologize for the interruption and also for not having the slides shared with the online audience. I think we are now back to the right situation. So I will get to your answer literally on the next slide. So here you can see an example of one of these interaction effects where we did a study where we had we tested recommendation quality for different lengths of recommendation lists. So we asked people about a list of recommendations. What do you think of the quality of this list of recommendations? And we had 3 different levels of a factor of list length, namely 5, 10, and 20 items. And we had 2 different levels for another factor of diversification, low diversification versus high diversification. And the interesting thing was that you saw an important difference between low and high diversification, but only for these very small lists of 5 items. For 10 and 20 items, you didn't really see a big difference. So if you were to study diversification, and you study it with 10 or 20 items, you would run your study and not find an effect. Or if you run it with 5 items, you would find an effect and think that that is universal. Right? If you do a study on list length, well, if you did that with a low diversification situation, you would say, well, list length doesn't really have a big effect. And if you do it with high diversification, you would conclude 5 items works better. Right? So doing these 2 factors at the same time actually helps you understand how these 2 factors interact with one another.
So let me kind of say that in just a slightly different way. So earlier I said that the answer to most questions is it depends. So you could ask a very simple question like, how does the number of items affect perceived quality? And it looks like there's a positive effect. Okay, but that positive effect only occurs under the condition of low diversification. Under high diversification, then the effect goes in the opposite direction. So understanding that is really important.
Yeah, and so you always have to think about what are you comparing against, right? And I think we have an example here. If you pick a really strong manipulation, then you're obviously going to find an effect. So let's say you're doing news recommendations, and I think you have to get a little closer this way.
Come closer to you? Is it where you have like a
no,
feedback?
it's close to the speakers.
All right.
So if you want to test recent news, right? So I'm going to do a news recommender where I only give you the items from the last month, or the last week even. I can test that against a system that gives you only items that are older than a month old, right? You're going to find an effect because you have completely different sets of news that you recommend to people, but that control condition is not very realistic, right? There's no news recommender that only recommends old news. You could also say, well, let's test only the at most 1 month old news against any news. But even any news, like Google News, doesn't give you any news, right? Like it kind of prioritizes newer news. You could also say, I'm going to test 1 month old news at most versus 2 month old news at most. Now we're getting more realistic, but now the difference becomes more and more subtle, right? So now you might run your study and not find an effect. So you have to very carefully pick your levels, the levels of your factor, to have something where reviewers would say, well, that's a reasonable test. But you also would think that, well, if I run this study on a couple hundred users, I will actually find a significant difference, right? So this is what is a realistic set of levels. Yeah, you have to kind of trade that off against, like, what am I likely to be able to detect? Does that answer your question a little bit? More or less. You want to ask a follow-up question on that? Yeah. No, I mean, this is an art almost more than a science, right? Like carefully selecting, and if we have some time at the end, we can actually get into some examples. So we'll try and do that.
I guess in the example that I gave around the number of words in an explanation for a recommender, if you took some explanations that are being used by practical systems, and you show that there's they tend to be 30 words plus or minus something, all right? And so you could establish that here's what's currently happening. Then I'm going to take something on the high end and something on the low end of that. Would be another way to think about this. So another thing that often happens is you will do a pre-test of your manipulation, where maybe you try this out on a small number of people to make sure that consumers are able to tell the difference between the levels that you have. And if they seem too too subtly, the difference is too subtle, then you're going to have to increase the difference between your levels.
Yeah, and obviously a related question is how long do you actually run your studies? And again, this is kind of where PopRox comes in as a useful platform. A lot of the studies that we at least run, we use Mechanical Turk or Prolific. It's a one-shot study, right? Like you can have users for about half an hour. Will they be able to detect differences between these different conditions? Maybe, maybe not. On PopRox, you can run a study for like several weeks. Hopefully that gives it a little bit more of an effect, right? So all of these things you have to keep in mind when you're designing these experimental manipulations.
Okay, so I now want to cover some of the design decisions that you're going to have to make. And so I'm going to use a notation that goes back to a very famous book by Cook and Campbell on experimental design. And basically what's going to happen here is time is going to the right, all right? And then the letter R there indicates randomization, random assignment, all right? X's are going to be treatments, O's are going to be observations, all right? So if we look at the design on the left, it's called the after only with control group. I think of this as the simplest design that we can possibly have. We have two groups. We have a treatment group and a control group. What happens first? Well, we take our subject pool and we use a random procedure to assign people to these two groups. Then what happens? Well, the treatment group gets assigned, gets exposed to our treatment. The control group doesn't. So maybe they're getting exposed to a baseline condition, and then we take a measurement. All right. Now there's a problem with this design, and the problem is that there's already existing differences between your users. So if we think about a news experiment, different people may have different levels of interest in the news. So Bart may have a lot of interest and I have moderate interest, and therefore when Bart gets assigned to a group, he's just more likely to click on stuff. Now the randomization covers you, but because of these differences between subjects, you're going to need a much larger sample size to overcome these, the differences, these inherent differences across your users. All right. So if we did a study of diets as an example, you assign people to one diet or another diet, and then you measure their weight after a few months on this diet. The issue is that people weigh differently to begin with. All right. Now we need to account for that. So the way you account for that is by taking what's called a pre-measure. All right. So the pre-measure establishes a baseline at the user level. All right. So there's a baseline level of how much Bart likes to read news. Here's a baseline level for how much I like to read news. Now we'll introduce the treatment, and you're going to make a comparison against that pre-measure. Okay. So the effect of taking this pre-measure is that you will reduce the requirement for large sample sizes because you've removed this user bias. I mean, the obvious example, if we're going to do a study on two diets, of course you want to weigh the people before you put them on the diet, right? And so these are pre-measures, and the power of this is that you're making a comparison kind of within that subject. Here's what they were before, here's what they were after. All right, another fundamental design is something called a crossover design. So crossover designs are where each user gets exposed to each of the treatment variables at some point in time. So let's just look at this. I randomly assign people to two groups. The first group gets treatment 1, the second group gets treatment 2. Take a measurement. Okay, now in the next week or next month, whatever the periods are, I flip that around. So I cross it over so that the first group now gets the second treatment and the second group gets the first treatment. So now you have a very strong basis of comparison because you're seeing how I, the user, respond to treatment 1. You're comparing that with how I, the user, respond to treatment 2. All right? So these are very strong designs. Now the hazard that you have with this is that you could have what's called a carryover effect. All right. So if the exposure to the first treatment changes how I respond to the second treatment, that's going to cause a problem. And so, in order to kind of reap the benefits of having a smaller sample size, one thing that we could do is rest the consumer for a period of time between the treatments. All right, so I get exposed to some basic treatment before you put me in the new treatment after that. All right. Let's see. Confounds and randomization. Boy, I'm not sure. I think when I'm moving, it's not a good thing.
If you move closer to this.
The ventilation. All right. Well, thank you. Yeah. So I mentioned this issue to you earlier. So the issue is that of. Can we turn down volume or something? So the problem that you're trying to avoid is if there is some other factor, this W, that is associated with both your treatment and the criterion, the outcome that you're measuring. All right. So what I told you to do about this was to randomly assign treatments. So if you randomly assign treatments, you remove the link between this other unobserved factor and the X, because nothing can be correlated with random. Something is completely random, it can't be correlated. All right, and so this is a real clever approach proposed by Ronald Fisher way back in the 1930s. How do you determine who gets what treatment? We'll do it at random, and then you don't have any issue with the treatment being subjects being different with respect to that variable. All right, there are more so unexpected confounds.
Yeah. So if you. Like one example is, so we talked a little bit about randomization. Randomization can sometimes actually be kind of annoying because you have to actually run two systems at the same time, right? And then randomly assign people. So sometimes it might feel intuitive to say, oh, I'm just going to run condition A first and then condition B. And often that's not a good idea. And I mean, news is actually a really good example of this. So PopRocks is a US news platform, and let's say we would run a study and we start our control group on October 28th. We let it run for about 2 weeks, and then on November 11, we start our treatment group. What's the problem here?
Yeah.
Do you know?
The election.
Exactly. not the same news. It's the major event of the US election that happens in between, right? So you get vastly different news probably, and that's going to completely mess up the entire experiment because of that, right? So you'd have to do random assignment. And in this case, I would even say maybe avoid that period in general, right? Because your results may not be generalizable.
So that's an example of a historical control. You're using results from one time period as a control condition and comparing it against with how people respond in a different time period. So historical controls are problematic because of a problem called history. Okay, so history is where something else happens that affects the dependent variable over the course of time. All right, and so in this case, the election is an example of this outside factor that's affecting your dependent variable, and it's confounded with time. All right, and so that's why we prefer to do, after only with control or before after with control, because it's happening. That history is going to affect both groups. Now then our only problem is, do responses during an election period also apply during non-election periods? And so that's a separate question of whether the experiment would generalize outside of that context of elections. All right. In the interest of time, I think I'm going to skip over the block designs. So this is there's enough information on the slide that I think you can get a sense for what this is and read more about it. The essence is, if you know things about respondents ahead of time, like you know their base level interest in the news, then you can work that into your design, where you randomly assign people who have high interest in news to treatment and control, and you randomly assign people who have low interest. And what that does is it reduces the chance that you get an unlucky random split where you get too many news hounds in one group and too many news avoiders in the other group. All right, so that's the basic idea of blocking. Determining sample size. I can't teach you sample size in 5 minutes. What I will tell you is that there's very good software that's out there. This G-Power will enable you to determine sample sizes, and so I'd recommend going back to a good engineering textbook, undergraduate textbook on statistics. So something like Walpole and Myers is, I think, a really good book, and they'll have a section on power calculations. So in essence, you're going to say, here's the power I want to have. So power means if you have a hypothesis that is actually true, right? So this level is different from this other level. With what probability will your study detect that? That's what power is. So can you reject a null hypothesis, an incorrect null hypothesis?
Yeah, so this is kind of the complementary to p-values, right? Like p-values is, will I actually reject a null hypothesis if it's not true? The power is, will I find the effect if it's true? I always call it the chance that you will graduate. Because if you're studying something that is real, you still might not find it if you don't run a large enough study. So actually, we have an example of that on the next slide.
You want to walk them through the example?
Yeah, because this is a nice intuitive understanding, right? Like, let's say you want to run a small study on whether married men weigh more than single men, right? So you find 4 married men, you measure their weight, you get like a mean and a standard deviation. You do the same thing for single men. And then you find, the difference, married men are 182 pounds, single men on average 170 pounds. That's a 12-pound difference. Is that a large difference? Intuitively, that's like 6 kilos, right? That's quite a bit. You can even standardize it. You divide it by the standard deviation, and you get like a value of 0.8. Cohen says that that's a fairly large effect. But because you've only done this with 8 men, your study is not significant, right? So your sample size was too small. Okay, let's do better. We'll do a study with 4,000 men. We'll do the same thing. We'll measure their weight of 4,000 or 8,000 men, 4,000 married men, 4,000 single men. But now let's say in this case, the difference that you find is only 1 pound, right? Is that a large effect? No, it's actually a very small effect, right? But because you did it with 8,000 men, you'll find a significant p-value. So you can write your paper and submit it to a journal and be like, look, we found a statistically significant difference between the weight of married men and single men. Is that paper going to get accepted? Probably not, because it's just a 1 pound difference, right? Like, does it really matter? Maybe medically there's some value to it. But the idea here is that the larger your sample size becomes, the more likely it is that you will find a significant effect anyway, if you just have even if you have just really tiny effects. So this is a waste of experimental resources, right? So finding that balance, that's a power analysis. And so this is something that is really important before you do a study, to really think about how many participants would I really need to run the study. And G-Power is indeed a very powerful tool for doing that, no pun intended. It's not very user-friendly. I actually am running a project now to change that. We're going to have a more user-friendly version of this. So watch this space.
Yeah. So I'll just, one kind of trivia bit on this. Is this an experimental design? Is this a true experiment, what Bart just described with the difference between married men and single men? So the answer is it's not an experimental design, because who's choosing to be married? Yeah. Is it you, the experimenter, or is it, all right. And so, this is a really good example of how there could be, some other factor that's linked to the choice of opting into the treatment group, being married, and also the...
You can try to random assignment on this, but good luck getting this through your ethics review board, right? That's
yeah. Okay. So selecting units. How do you select your units? So strictly speaking, the results of your test will apply to the sampled population. Okay, so if you do a study in early November on news in the US, your results will apply, in the US during election periods. Will they apply in Canada? I don't know, probably not. So keep that in mind. When you're doing experiments, though, I'm just going to mention that the focus is on establishing the cause and effect relationship for at least some population. Usually we will establish boundary conditions later, right? And so you'll establish that an effect exists, and then at a later time it could be tested in other contexts, and you discover that maybe it doesn't hold in this other context. That's an opportunity for a contribution, because then you can explain why and what it is. It's an interaction, right? So under these conditions in Canada, this effect doesn't hold. In the US, it does because of the election, as a trivial example. But kind of adding moderators, adding these boundary conditions makes for a much stronger paper. I think we're coming up on, so analyzing results. This is what you learn in your, this is what statistics professors love to teach, is how to analyze things. So all I'm going to mention on analyzing the results is go to a good undergraduate textbook. Walpole and Myers is one that I love. Montgomery and Runger is another classic. Tamhani and Dunlop is one of my favorites. There's also a set of experimental design and analysis of experiment textbooks that would be sort of a junior, senior level undergraduate class that would take you, to the next level. But what's in the basic undergraduate, stat class is really all you need for the experiments that we're talking about here. So I'm going to turn it over to Bart, who's going to get into, Should I spend a couple minutes on internal and external validity?
Yeah, why not?
All right, so here are some concepts that you need to know about. Internal validity versus external validity. So internal validity is whether your experiment can unambiguously determine cause and effect. So is it marital status that is causing a difference in weight, all right? Or could it be due to something else, maybe age? You know, younger people weigh less and are less likely to be married.
Affluence.
Affluence could be another example of a confounding variable. So those would be threats to internal validity. External validity is something completely different. So you can have an internally valid experiment where for these subjects in this context, I can prove that, that my X is causing the Y. But that doesn't mean that it holds more broadly. So what external validity means is, do the results of this hold in other time periods, in other contexts? You know, is what you learn in an experiment in summer going to apply in winter? I don't know.
And the context that I mentioned earlier, this is a little bit of a left field example, but that idea of like when you're running a study offline using the movie lens data set and you're doing your calculations, and then you're running the same study online and you'll find different results, that's a really good example of those offline tests don't have the external validity, right? That's the issue there.
So there's often a trade-off. Stuff that you do in a lab, you have a lot of control over all these other factors, but stuff that happens in a lab may not happen in the real world. But you know, when you do stuff in the real world, well, then it's noisier because you have all these other factors that could enter into it. So that's something you have to manage. What follows on these slides are some well-known threats to internal validity. All right, and so selection is where your treatment and control groups aren't equal to begin with. So maybe married men and unmarried men are not equal to begin with because their ages are different. All right. Yeah. Hawthorne effects. Or you want to interject something on that?
Oh no, I was going to say same with like if you're just comparing two different news platforms. If they are from different news outlets, they probably have a different readership, so they differ in other ways than just using different platforms.
Yeah. So the remedy to this is randomization. All right. Hawthorne placebo effects. So that's where if I know that I'm being treated, I respond differently. Oh, I know I'm in a study, therefore I better read a lot of news. And so the remedy for this is to have a placebo. A placebo is going to be so Bart and I could be in different groups. I get something that's like a treatment. He gets the real treatment, but we both think we're being treated, and so then that would affect us both the same way.
And this effect becomes particularly important when you have these within subjects designs, where you kind of know what the other treatment is, right? So you did one condition already, and now you're doing the other condition. While maybe you still know what happened in the first condition, and it's going to affect how you behave.
Experimental mortality is where you have a differential loss in your subject pool. So let's say I have one treatment that is, I'm going to show you the most gory, depressing news possible. And then the other group just gets the normal mixture of news. Okay, well, you may have a bunch of people who don't like that treatment, and they drop out of the panel, and then only the strongest or the people survive. So
if you measure optimism at the end of that study, you would think that the people who got the happy news are more optimistic, but the people who didn't drop out of the gory news condition, they're probably very inherently optimistic, right? So now the mortality actually affects your outcome variable.
So I think the remedy here is you need to be transparent. We had a much larger attrition rate in our treatment group. And acknowledge that's a possible flaw in your study.
I'm afraid to say that I've done studies where this was actually a statistically significant difference. Like people would drop out of the condition that I indeed luckily expected to be kind of a pain to use. But yeah, it happens.
History we've already talked about. So something else happens that affects them. The remedy for this is have a control group. Interactive testing effects. Interactive testing effects are where taking a pre-measure affects the way people respond to the treatment. So if I ask you a bunch of questions about news literacy or whatever, and then I start exposing you to news, maybe you're more likely to read it, all right? And so what's the solution to this? Don't take a pre-measure, okay? The downside of that is you're gonna need larger sample sizes, as I mentioned earlier. There's another design called the Solomon 4 group design, where on 2 groups you take a pre-measure, 2 groups you don't. That's another design you can Google on Wikipedia, will give you a good. All right. Finally, there's the regression effect. So the regression effect is where you assign people to groups, or you assign units to groups based on a pre-measure. All right. So a classic saying is you won't do as well in rollout as you do in test. So this is a regression effect. What is this saying? So if you test a bunch of things and then you choose the factors that did best in your test to roll out, you will often observe worse performance when you roll it out to much larger sample sizes. And so why is this? It's because you're capitalizing on chance. You're selecting the ones to get rolled out for those that did best in this, in your pre-studies. All right, and so maybe they do better, but they also by chance performed well in your testing conditions, and so that's why you'll have what's called a regression of the mean.
In offline testing, we do cross-validation. This is something we actually don't do much in these controlled experiments. Maybe we should. Right? That could be a solution to it.
Bart, why don't you jump in and?
Yeah. So going back to this idea of pop rocks, there's. When I do studies, I will admit, I never get to do the study that I really want to do, right? I can't really do very complex studies because I'm running something in my lab and I can run something for like half an hour on Mechanical Turk or a platform like Prolific. And so I can't really do these long-term studies. And so you get these single-shot studies, you get this carryover effect, you get these interactive test effects, and we have to deal with it, and there are ways to deal with it. But, what we're going to talk about in the next tutorial is a platform that allows you to just ignore these things because we have a platform that takes care of it, right? So that's really nice. The other thing is the validity, right? If I am running a study on Mechanical Turk or Prolific, I'm going to get people who are paid to do research, and that's why they're there, right? I'm not going to be able to do studies with people who are just reading their newsletter or are just doing their movie recommendations, right? Having a platform is a real big benefit there, and it's something that we don't really have much in this space, and which is why we are so excited about this new platform. So here's additional reading from the part that Ed has presented so far. I'm going to take just 1 minute for questions because we threw a lot at you. Anything? Yes.
So boundary conditions mean this. Let's go back to Bart's example about the number of items that I show you in your perceived quality of the recommendation. Okay, so in the low diversity setting, all right, we may conclude that more items means higher quality, all right? But is that always the case? Well, there could be other circumstances where that's not the case. So if I'm in a high diversity setting, then I don't want to have a lot of items. Okay, so that main effect of how many items affecting the quality only holds under certain circumstances, like low diversity. But when I'm not in those circumstances, if I have high diversity, then all bets are off. In fact, it might flip around and go the other way. More items could be choice overload. Yeah, so it's you know, this relationship that I'm hypothesizing holds under these conditions, but not under other conditions. That's what I mean by the boundary conditions for my theory. The theory holds here, not here.
Yeah. So kind of the takeaway there is always study more than you intend to study, because you may not know about the boundary conditions of your study, right? I've had several situations where I try to show a relationship and I realize, oh, but this is only true for domain experts, or it's only true for domain novices, or it's only true for older users, or only true for younger users, right? Like, these things are really important to take into account, because otherwise you might make generalizing claims that are actually not warranted. So now we're going to talk about the outcome measures, right? We have some study designs. And so now we have to think about, okay, what are we going to measure to see if our system is making an improvement? And so the starting point here is, what is the goal of your recommender system, right? Are you trying to improve item ranking performance? Are you trying to increase user retention? Do you have some notion of an improved user experience? Are you trying to get users to fulfill a certain goal? Are you trying to achieve some positive societal outcomes, right? Like fairness, for instance. And how are these things related to one another? And the interesting thing here is that with offline tests, you can really only do number one, right? And one of my big gripes with a lot of recommender systems research is that people do number one and then assume numbers 2, 3, 4, maybe even 5. That's a problem. When you do A/B tests, you get number 2 as well, if you run them long enough. If you do experiments, you can add number 3 and number 4 a little bit, which is really nice. The nice thing about running user experiments on a real platform is that you can actually get all 5. Yeah. So we have these traditional metrics, you know, we can have like ranking, and we can have some success and conversion rates. I'm actually going to skip over this because I assume that most people know about this, right? This is the traditional recommender system stuff. Okay. We also have equity, fairness, diversity. We have metrics for that as well, right? A big question is, do these metrics actually reflect real-world perceptions of diversity and fairness, etc.? Right? We actually don't know very well. I know there are some people who are studying this, actually. Then we have these online behavioral metrics, right? We can do engagement, we can construct some metrics of interest, we can actually get user retention when we do these online studies. Again, I think for most people this is somewhat known. And so now we can talk about subjective metrics. This is why I'm here. First of all, why would we want to study subjective metrics? Well, one of my formative experiences of why I decided to do this is because of a study I did with Microsoft Germany back in 2008, where they were testing a video clip recommender against a system that would give people random recommendations. This was in a European framework project. They had randomly assigned people to the personalized recommendations condition, and the other half of the people got assigned to this randomized, just basically random recommendations. It's a video clip system. People were watching video clips on a daily basis, and after a week of this random assignment trial, they found out that the people who got the state-of-the-art recommendation algorithm actually had a lower number of clips that people clicked on, and a shorter total viewing time of video clips. So it looked like the experiment had failed. Random was doing better than a state-of-the-art algorithm. Okay, let's see what happens here. So we actually did some subjective evaluations. We asked users about the quality of their recommendations, right? Literally asked them questions. And we found that people in the state-of-the-art algorithm condition found the quality of the recommendations higher than people in the random condition. That's a good thing, right? We also measured the perceived system effectiveness and their choice satisfaction. How much do you like the clips that you click on? How effective do you feel the system is? Both of those were positively related to the perceived quality of the recommendations. And we found a negative correlation between system effectiveness and the total viewing time and the number of clips that people clicked on. So what happened here? The system with the random recommendations was simply a pain to use, right? You click on a clip, I don't like it. I click on another clip, I don't like it. I click on another clip, I don't like it. By the time you get to a clip that you like, you've watched so many movies, so many video clips already that you've racked up more clicks and more total viewing time than the person in the personalized system who clicks on the clip and likes it immediately. So I went back to Microsoft and I said, I think y'all are using the wrong metrics. Can you try and see how many clips people watch completely from the beginning to the end? And that metric was higher for people in the state-of-the-art algorithm condition than in the random condition. So by using these subjective metrics, we were able to figure out that the behavioral metrics were actually doing something different than the researchers expected they would. Okay, so we're talking about user-centric metrics. Based on this study that I just talked about and several other studies, Martijn Willemsen and I and a bunch of people on the program created this user-centric evaluation framework. So this basically explains how certain things that you might manipulate in the system, so these are these factors that Ed talked about, how they influence your perceptions of those aspects, the subjective system aspects, how they subsequently influence your user experience, things like perceived the system effectiveness and choice satisfaction, how those things might be influenced by situational and personal characteristics. Those are those boundary conditions that you might want to keep into account. And we always link it back to actual interaction, right, to actual user behavior. So this is really nice because it allows you to run these studies, to actually measure these things, and to get kind of robust, generalizable study results with all of these things, by taking all of these things into account. So yeah, here are our subjective system aspects and our user experience. What we typically do is we try to measure these things. Here are some constructs that you have there, like perceived recommendation quality, perceived diversity, understandability, choice satisfaction, choice difficulty, system satisfaction. We measure these things using multiple items that are each measured on like a 5 or 7 point scale. And I'll talk about the reason why we do this with multiple items for each of these constructs. By the way, it's okay sometimes to cut corners on that and use just a single item per construct, especially now that we have established this over time. You know, like some of these metrics are a little bit more established. If there is a construct in here that you like, you take one of the scales that we developed. If there's something else that you want to measure, again, think about what is your system trying to accomplish. Develop your own scale. I have a reference to a book there that is about scale development that is really good.
Mention that there's been a lot of work done on measuring different constructs, and so it's best to find a scale that's already been tested and validated on users. Yeah. But if that doesn't exist, then you can create your own, but that's a lot of work.
Or you can adapt it to your purpose. That's usually the best solution, is you take something that exists, but you kind of slightly adapt it to your purpose. Now, this was something that I developed in terms of these kind of artificial user experiments where, you know, you run a study online for like half an hour and that's it. Now we are moving to a situation where we have people using a real system, and in that case we can actually measure users' uses and gratifications. I think Ab can tell a little bit more about that.
Yeah, so this kind of goes back to the first keynote that we heard this week about focusing in on what the user's goals are. Now, there's been work done in communications dating back to the 1950s on, what are the user's goals with news media and media in general, under the heading of uses and gratifications. And so these are dimensions such as I want to stay up to date on things, so sort of a surveillance. There's something I need to stay up to date on, and I want to, so how this is contributing to my personal goal of staying up to date is that this news source keeps me up to date on this. It could be a social benefits. So I read some newspapers so that I have something to talk about with my colleagues at work. I have something I can drop into conversation with my wife over the breakfast table, right? Or it could be, so that's social facilitation. There could be just, I'm looking for something quirky. Some strange story. The bank robber who stands in line to rob the bank. It makes you smile. And so maybe you read a news source just to have that little dose of humor in your life every day, which is kind of linked to serendipity in a sense. So that's what these uses and gratifications scales measure.
And these have kind of been developed for news media, but they also apply to some extent to other media like movies and music. And there's ways to adapt these kind of somewhat more broadly to a lot of the things that we do recommendations on. These things kind of work. It's like, really the goal here is to really think about what are people using your system for, right? And a big problem here is that if you're running a study for like half an hour on an online platform, you probably cannot measure this, right? Because why are people using the system? Because you pay them to use the system, right? But if it's a real system, then these become actually very interesting to study. Yeah, go ahead. Yeah, of course. Yeah. So the question is, what about the fact that when people have a bad experience, they're more likely to leave a review, right? That's kind of the idea. Now, there's a couple of ways to deal with that. One is, hopefully your randomization somewhat takes care of that, right? And then the idea is that, if your system is leaving a really bad experience for some people, in certain conditions, well, that's a signal you probably want to know about anyway, right? So it might actually be a good thing that is happening. But if you want a more kind of normalized result of the user's experience, encouraging them to answer these questionnaires is a good idea. So again, kind of going back to the PopRocks platform, we are going to create a delicate balance between getting people to be on the platform because they want to read news, but then also incentivizing them to fill out these surveys every week, even if nothing bad happens, so that we actually get kind of a reasonable set of metrics from them. Yeah, it's a really good point. Yeah.
Well, briefly to that, you can look at, for example, with the construct of satisfaction, episodic specific satisfaction. So how was that cup of coffee that you had this morning? So with a specific episode versus you go to that coffee place every day for your coffee. Tell me in general, in kind of a steady state situation, how satisfied are you with the coffee at this place? All right, and so being specific about whether you're measuring satisfaction with this with this service encounter versus more generally is one way to address that issue of how you frame that question. There's also situational characteristics. If you ask me about something after I've been fed, I'm in a good state of mind. Whereas if you ask me something I'm tired and grumpy, that's kind of a well-known problem that creates biases due to situational characteristics.
So we went from user experience metrics to kind of practical goal-related metrics to now maybe even aspirational goals, right? What are people trying to accomplish in the long run? I wrote a paper in 2016 about kind of trying to push the boundaries of the recommender systems field, and Martijn Willemsen and Mike Ekstrand wrote a paper, like we literally presented at the same conference, about trying to attain people's long-term goals with recommender systems. And so we're trying to actually establish now some metrics to measure that as well, right? So is a recommender system capitalizing on kind of like some short-term things that you're interested in, or is it actually covering a broader set of interests that you're interested in? Is it actually helping you understand your own preferences? Is it helping you develop your interests, right? Rather than, again, just trying to show you stuff that you already like. And so is it supporting your self-actualization, right? Is it actually contributing meaningfully to your life beyond just your short-term goals? These are metrics that are still very much under construction and in development, but I encourage you to think about these kind of really kind of aspirational long-term goals when it comes to recommender evaluation. And then you have to think about, these boundary conditions, right? Maybe something like age and gender, location, education, affluence, political leaning, domain interests. All of these things can actually influence how people perceive your recommender system, and more importantly, the treatment that you're applying to them, right? So it's really important to measure these things, even just from a perspective of fairness, right? We do fairness in our offline evaluations. You have to do fairness in these types of evaluations as well. Making sure that your treatment actually has an equitable impact on the users that you are evaluating. Another important element of that is in participant selection, right? A lot of online research is done on Western societies, right? In Europe or in the United States, and we are not really testing whether our systems also work in other countries. So it's important to keep that in mind. And then situational characteristics, right? Trust has a really big impact on how people perceive LLMs, right? So LLM-based recommender systems, I would always measure trust, like not just how much people trust the LLM, but also how trusting they are in this particular situation, even before they start using the LLM, right? Your mood, your current goals, like thinking about these uses and gratifications, taking all of these things into account is really important. In PopRox, we already do all of this. So we already have these metrics in place. People get these questions on a regular basis. We're trying to encourage them to use them. And so if you're running a study with us, you already get these practically for free. If you want to add more, we can talk about it. Okay, so I talked a little bit about this idea of multi-item measurement. And this is important because when you're doing things with single items, it sometimes lacks what is called content validity, right? If I ask you how satisfied are you with your recommendations, different people have different reasons to be satisfied, right? And so what this kind of reduces the precision and the conceptual clarity. If I'm saying like, okay, how much do you, like, how serendipitous are your recommendation? Do users even know what serendipity is? Do we even agree on what serendipity is, right? So doing this carefully with multiple items allows you to establish a shared conceptual understanding between you yourself and the study participants, you and the reviewers and the readers of your paper, right? So this is a really useful concept, and the way you do this is with a multi-item scale. And the theory behind this is that whatever question you ask when you're asking, when you're doing these subjective measurements, it's always going to have some error, right? You're never going to be able to really measure something. Yes, question. So the item, It's a single question that you would ask. Yeah, yeah. So you ask a single question, and you would get a a measurement of satisfaction, hopefully. But whatever, there's always some error in that question. And so how do you deal with that? Well, a problem with that is that your regression coefficients can never be really high if there's a lot of errors in that question. So what do? You actually pick multiple items, and now each item becomes a yardstick for every one of the other items. Now this helps you do two things. One, if one of these items is kind of a ugly duckling, kind of drops out, you can remove it and continue with your study. It's okay. Also, you can kind of check the average correlation between these items, and you can use that to kind of attenuate your regression coefficients. So you actually get more precise measurements by doing this. The downside of this, you have to ask I think the scientific term is shit ton of questions, right? I've run studies where, like, at the end of the study, I ask users like 50 to 100 questions. If you run the study on Mechanical Turk or Prolific, you can totally do that. People are happy to do it. There is a little bit of, like, questionnaire fatigue, but it's actually not that bad if you design your questionnaire carefully. In a real platform, Google will never ask someone 50 questions in their regular use experience, right? Like, there may be an interstitial on YouTube with like a single question. So there's a little bit of a trade-off there in how you want to do that. But if you're measuring something that's brand new, something that nobody's ever studied before, it does pay to do these multi-item measurements. Yes? So can you ask some questions to some people and some to others? Yes, but that makes that idea of using them as a yardstick for each other a little bit more difficult, right? So you can, there are really complex ways of doing kind of like a semi-random assignment. In the end, they're not really that worth it. Yeah.
And what you're really trying to do is reduce measurement error. If I take a single measure, it's that, I'm measuring the thing I want to measure, but then it's, polluted with air. So what did you do in your high school science class? Well, you measured things multiple times and then you averaged them. That's kind of what you're doing here. You're taking multiple measurements of the same thing, and in doing so, you're reducing the amount of measurement error. Yeah.
And what we do in PopRocks is we end up asking only a single question per construct because, we are dealing with real users, but we're asking those questions kind of repeatedly, right? Like every 4 weeks, we have a 4-week cycle where we cycle through these different questions. So we have a kind of long-run baseline of that establishes somewhat of the validity of these questions. And so finally, I want to come back to something that Ed mentioned early on, which is this idea of applying theory, right? I think if you want to learn something really useful from a study, if you want to publish a RecSys paper, you need to do more than just demonstrate that something works, right? I think this is a big criticism that I see increasingly leveraged against like these LLM studies, right? Like it's how do we do LLM studies? We applied LLMs to X and we found that it works. Sure, but why, right? You have to have some sort of theoretical construct behind why this is working so that other people can actually learn something from that, so that you have generalizable knowledge, right? So there's a couple ways to do that. First of all, you need to come up with your theory of like what is behind this. And then to demonstrate that theory, it helps to not just have your final behavioral or subjective outcome, but to measure some mediating variables that actually track with the theory. I'll show you an example of this. So we did a study it was presented at RecSys in 2010 on choice overload. So the idea behind choice overload is that if you give people a lot of items to choose from, that increases the benefit of the choice. But at some point, it becomes a very big pain to actually choose to actually find what you're looking for. If you've ever been in a US supermarket trying to buy peanut butter, you know what I mean, because there's like 50 different types, right? And I get overwhelmed. So there's increasing benefits with a larger list of items, but the benefit kind of levels off at some point. And there is a kind of almost steady increase and actually accelerating increase in the cost of making a decision as these item sets grow larger and larger. Is this also true? And so the consequence of that is that you have kind of like an optimum somewhere. Is this also true for recommender systems, is what we asked ourselves. So we did this study. What's the effect of the number of recommendations? What's the effect of the composition of the recommendation list? We did a study with a single factor with 3 levels. Level 1, show people the top 5 recommendations. Level 2, show people the top 20 recommendations. These were news recommendations. We elicited their preferences and then, ran a state-of-the-art back then matrix factorization algorithm. Showed them the top 5 in one condition. So 1/3 of participants got top 5, 1/3 of the participants got the top 20, and then 1/3 of the participants got the top 5, and then 15 items sampled lower down the list. So item number 99, 199, 299, 399, etc. Even that last one still had pretty good recommendations because this was on, I think, the Movie Lens 1M data set, so it has like over 6,000 movies in there. So even the number 14, over 60,000 movies. So even movie 1499 is still a decent movie there. And another interesting thing here is that you get the top 5 in all conditions, right? So you can't accuse us of not showing people good items because every condition has at least some good items. This is what we found. And if we had only measured choice satisfaction, we would probably not have been able to publish this paper. Because look at it, there's almost no difference, right? That last condition is slightly better, but it's not statistically significant. So what are you going to do? We apply the theory of choice overload. So this is actually the model that we show in the study. What is this? Well, you see here the top 20 compared against the top 5. The linear 20 is linearly sampled down the list. Linear 20 against top 5. And we measured. What is the perceived recommendation variety? Well, it's higher in both the top 20 and the linear 20, actually slightly even higher in the linear 20. What is the perceived recommendation quality? Well, the higher the variety, the higher the quality. That's this line over here, right? And then the linear 20 had kind of a lower quality, right? Because there's items lower down the list. This was the quality of the list of items. And yeah, that had a lower quality. Recommendation quality leads to choice satisfaction, right? The better the quality of the recommendations, the higher the quality of my choice. But recommendation quality also leads to choice difficulty, which negatively affects choice satisfaction. So here you have that trade-off between quality and difficulty on choice satisfaction. So even though the overall result was kind of disappointing, the theory actually shows you that choice overload is happening here. Interesting question. Why is this one slightly higher? Well, there's an additional line going here from linear 20 to choice satisfaction. Unfortunately, we did not have good mediator variables to measure here to find out why this is happening. Our suspicion is that it is because, well, when we looked at people's choice behaviors and even their browsing behaviors in that list, we did kind of like a poor man's eye tracker study. Most people look in the top 5 and they actually choose from the top 5. But in the linear 20, you pick an item from the top 5 and you compare it against the items lower down the list. So you're actually more satisfied because you didn't pick the bad items. So one of Dirk's conclusions in the 2010 RecSys talk was we should give people more bad recommendations. Just because they'll be happier with the good items that they end up choosing, right? So give them good recommendations, but also give them a couple of bad ones to justify their choice. It's a little bit of a silly outcome, but it tracks with the idea of choice overload, right? And when you run this as a path model, you can actually get your statistical values for all of these things. And I have some online study materials on how to run these types of models. So that actually does conclude the main portion of the tutorial. Are there questions? Yes. So what was your first question? It is diversity, but I think it's more than just diversity, right? Diversity is about kind of genre and topic diversity. This was quality diversity, right? And we did not measure for that. So if we had, then maybe that would have been an explanation there. Why would you measure this? Because in the end, this ended up being a starting point of a lot of research about how do we increase the variety of the recommendations, which increases the quality, without increasing choice difficulty. And the trick was to find a way to do top 5 recommendations that actually have a high variety, because top 5, like you see here, top 20 actually has a really high choice difficulty. And so that goes back to the results that I showed earlier of the diversified top 5 actually having a higher choice satisfaction. So by virtue of doing this analysis, we were able to kind of generate hypotheses for new studies. Yeah, it's a very good question. Other questions? A question in the chat. Can I open the chat is then a big question. Here we go. Say it again. Oh, on the TV. Okay. Oh, yes, of course. Here. There we go. Chat is opening. Okay, okay, so I'm guessing we're no longer muted because this was from a while ago. Yeah. Other questions? Any other questions? Yeah. Yeah. So it's kind of like, how do you deal with kind of like the novelty effect of your manipulation, right? Like, people might just be very happy to have something new. So one thing is, if you are able to track things for longer, you would imagine that the novelty dies out, right? So if you have the ability to run a study for several weeks or months, you can actually track your outcome variable and see if it reduces. The other idea would be to create a placebo condition, right, where things are just slightly different anyway, and then hoping that doesn't, that effect doesn't overshadow the effect of your manipulation. Yeah. Good question. Other questions? Yes. Yeah, so should we discard click rates and just go for conversion rates if clicks are kind of unsuccessful exploration? I think there's something to be said for that. I think there's also a potential to do a metric that does like clicks per conversion, which is kind of like efficiency, right? That could be another metric that you could potentially look at. The problem is conversions happen rarely in many cases. and may happen for other reasons, right? So sometimes browsing is actually good. I would say in that case, add some subjective metrics to find out if the browsing is pleasurable browsing or annoyance browsing, right? Like, I think that's really, really a good question. I think a lot of luxury brands actually like people to browse. And people like browsing those. Like, I love going on the Apple website and just see what shiny stuff they have, even if I don't always buy it. Yeah, I think a subjective metric might actually be a better way of distinguishing between the bad browsing and the good browsing.
So let me give a slightly different answer to that. It's a very common situation, and I would say that conversion is a downstream metric that happens far downstream, and as Bart mentioned, it's a fairly rare event, and you have to wait a while. And so what we often want to do is construct upstream measures that are predictive of that downstream measure. All right, and so there's a concept called predictive validity. So predictive validity is where some measure portends some future measure. So the classic example is I use a standardized test to predict your performance in graduate school. Your performance in graduate school would happen way downstream, but we would then we would have a debate. There's debates about whether these standardized tests have that quality of predictive validity. So in the context of news, for example, what I ultimately may want is a paying subscriber. That happens way downstream. But I've done a lot of work to kind of identify these upstream measures. So like the frequency of reading has predictive validity to keep you as a subscriber, stronger predictive validity than the number of page views. All right, so lots of people were optimizing the short-term metric of page views instead of the frequency of reading. And so, I believe, kind of establishing the predictive validity of your upstream measures is critical to addressing the situation that you've just described.
Those who were here on Monday will know that the coffee break was fantastic. So I do not want to keep you away from that, but if you have more questions, feel free to come up here and we'll walk there together and we'll answer them. Thank you.